Today we're going to do test 3 for my Intro to Statistics class. So if you want to see more videos like this, make sure to subscribe, smash the like button, and join me in the simultaneous sip. Question 1. Here are the GPAs of some of Dr. Weselcouch's YouTube commenters, which can be you. Is this significant evidence that the mean GPA of Dr. Weselcouch's YouTube commenters is not 3.90? Explain in simple language what this result means. So we want to do a significance test, and here our null hypothesis is mu is equal to 3.90, and our alternate hypothesis is that mu is not equal to 3.90. So when we compute the probability, it's going to be two-sided. So we need to compute the mean and the standard deviation. So let's do that in Minitab. We could go up to Statistics, Summary, Descriptive Statistics for our GPA that I already typed in. And you can see right there we get the mean and the standard deviation. So we see that X bar, so our sample mean, is 3.928. S, which is our sample standard deviation, is 0.051. N, which is our sample size, is 10. And so we need our t statistic, because here we don't know sigma, so we need the t statistic, which you get as x bar minus mu, so 3.928 minus 3.90 over S over root n, 0.051 over the square root of 10. Plug this into a calculator, and we get our t statistic is 1.7362. And our degrees of freedom is 10 minus 1, which is 9. So let's go back to Minitab. Probability, distribution plot. We've done this a million times. Display probability, the t distribution with 9 degrees of freedom. We have a specific x value, and we want to find equal tails because we have a two-sided probability. Our x value we found is our t statistic. And Minitab now gives us the areas of these tails. So P is equal to 2 times those areas, which is 0.0583. So our P value is 0.1166. And in plain language, since P is greater than 0.05, what can we say? This is not significant evidence that the mean GPA is not 3.90. Question 2. A study that looked at the effects of smashing the like button on students' test scores used students who smash the like button and students who don't. The 10 students who smash the like button had mean test scores of 82 points with a standard deviation of 5 points. The 13 students who don't smash the like button had a mean of 75 with a standard deviation of 8. Find a 90% confidence interval for the difference of the two means. Explain in simple language what this result means. So let's write down all the information that was given to us. We see that N1, the number of students who smash the like button, is 10. Could be more. It could be you. X1 bar is 82 points. S1, the standard deviation, is 5. N2 is 13. X2 bar is 75. And the standard deviation is 8. And since we're looking for a confidence interval, we're going to need T star, and we can get it from this table here. But first, our degrees of freedom is 9, and T star we could see is 1.833. Okay, and now we're basically done. Let's just put it all together. We know that a 90% confidence interval for the difference of the two means is x1 bar minus x2 bar plus or minus T star times the standard error, which is S1 squared over N1, or the square root of this, plus S2 squared over N2. Now we could just type all of this into a calculator, and it works out to be, if we want to show some work, 82 minus 75 plus or minus 1.833 times the square root of what's S1? 5 squared over 10 plus 8 squared over 13. And evaluating with the calculator, we get 2.01 to 11.99. So what does this mean? It means there is a 90% chance, or we're 90% confident, that the actual difference in average test score is between 2.01 and 11.99 points. Question 3. Dr. Weselcouch would like to know what proportion of his YouTube viewers are subscribed to his channel. He will survey a random sample of viewers and compute a 95% confidence interval for the proportion who subscribe. He estimated that the proportion will be about 0.4. Find the sample size needed if the margin of error of the confidence interval is to be about 0.02. Explain in simple language what this result means. So we're given that p hat is equal to 0.4. Our margin of error is 0.02. And we could see from the table that z star is equal to 1.96. And now we're basically done. Why is that? Because we know that n, our sample size, needs to be at least as big as z star over m squared times p hat times 1 minus p hat. And we know all these values, so let's just plug it in. So n is equal to 1.96 over 0.02 squared times 0.4 times 0.6. Again, plugging this into a calculator, we get n is equal to 2,304.96. But of course, we can't have 0.96 of a person, so we must round up. So our sample size is 2,305. So what does this mean? It means if 2,305 people are sampled, we are 95% confident that the measured proportion from the sample will be within 0.02 of the actual proportion. Question 4. A study at Roanoke College compared students who subscribe to Dr. Weselcouch's YouTube channel with students who don't subscribe. Of the 1,208 subscribers, 583 had made the Dean's List. Of the 815 in the group of non-subscribers, 273 made the Dean's List. Is this good evidence that making the Dean's List is more common among subscribers than non-subscribers? Explain in simple language what this result means. Find a 99% confidence interval for the difference in the proportions. Explain in simple language what this result means. As with the other examples, we should just start by writing down the information that we're given. So N1 is equal to 1,208. P1 is 583 over 1,208, which we work out to be 0.4826. N2 is 815, and P2 hat is 273 over 815, which works out to be 0.3350. And then the pooled proportion, which we call P hat, is if we group everybody together, subscribers and non-subscribers come together in harmony. We get 583 plus 273 over 1,208 plus 815, which works out to be 0.4231. And our Z statistic, which we know is P1 hat minus P2 hat, over the square root of P hat 1 minus P hat 1 over N1 plus 1 over N2. We could just plug in all these values and we get our Z statistic is 6.591. Okay, I guess we should have written our null hypothesis is that the two proportions are equal, and the alternate hypothesis is that P1 is greater than P2. That was the whole point of finding the Z statistic in the first place. So let's go over to Minitab and find our probability based on our Z statistic. So here we have the normal distribution. We're looking for the right tail. And our X value is the Z statistic we found, which is it's a big number. So we plug it in and we get a p-value of 0. Okay, so what does this mean? Well, p is approximately equal to 0. Again, what do we want to do? We compare it to the number 0.05. Is it bigger or smaller? So since p, our p-value, is less than 0.05, this is very strong evidence that the proportion of my subscribers who makes the Dean's List is larger than the proportion of my non-subscribers who makes the Dean's List. For part C, we could get Z star from a table, and we get Z star is equal to 2.576. And so we know our confidence interval is P1 minus P2 plus or minus Z star times the square root of P1 hat times 1 minus P1 hat over N1. Again, we know all these values, so we're just going to plug it in. Plus P2 hat 1 minus P2 hat over N2. Okay, so plugging in these values into a calculator, we get 0.0912 to 0.2040. So what does this mean? Well, it means there is a 99% chance that the proportion of my subscribers who makes the Dean's List is between 0.0912 and 0.2040 greater than the proportion of my non-subscribers who makes the Dean's List. Make sure to subscribe for more Coffee and Math with Dr. Weselcouch. Don't text and drive. Bye-bye.